Okay, the last thing we need to understand is complex loci. Now, loci are sets of points. So these can be all manner of different things. They can be from one point to a line, to a curve, to a filled-in shape. It's got lots and lots of possibilities. Excuse me. So what they'll be asking you is to actually understand this. So the first thing you need to understand is that the loci of involving real and imaginary points so the real or imaginary part of it, they're just straight lines. That doesn't mean anything, I know, but let's have a look. So what they're going to say is something like, show me the loci where the real part of the imaginary number equals 4. All right, so any imaginary number that has the real part of 4. The real part is on Y, so here's 4, here it is. That's the loci. Okay, and then if you had an imaginary part, it would be the other way around. Any loci that are dealing with involving, we use the same word, involving the modulus or the argument, all right, no, modulus, or R, not argument, is talking about a length, all right? So if they say something like the complex number where the modulus is 3. So any complex number that is 3 away from 0, what does that give you? Correct, a circle. That is 3 away. So anything on the circle that is 3 away is the answer to that. All right, they could move this by saying something like the modulus of any complex number but 2 plus I equals 3, all right? So they've moved the centre of it. They've moved the centre to, this is the tricky part, to minus I. All right, so 2 minus I is where? 2 across, 1 down. Now we need the circle away from that. So 3, 3, 3, 3, 3. So it's going to be, that one's way away. All right, something like that anyway. Same circle, because it's the same distance. All right, what's next? If they do this one, oh, no, we need the wrong colour. All right, where they're saying this point, the distance from this point is the same as the distance from this point. What complex number is the same distance from both of these points? So here are these points, Z1 and Z2. What are the points that are equidistant from both of these points? Right, there's one straight in between, right, halfway. And then there's everything perpendicular to that. So it's this line here. All right? So we might have to find the gradient of this line and find the etc., etc. So we might need to find out what the midpoint between those 2 points are. So average them, and then find the gradient of these 2 lines. All right, so those are the basic questions. They need to be equidistant. That's the ones they're likely to ask you to understand whether you know how a loci, so a group of complex numbers, remember complex numbers are a point on an Argand plane, come together to answer a question. Good luck. That's it, folks.